Hi, welcome back to Clinker Chat. This is SmartCrete series where we talk to interesting people in the world of concrete about great things happening towards emissions reduction and innovation in general. Today we had the great pleasure of speaking to Bruce Perry, Technical Account Manager, and Olivia Alexis, Product Specialist at Cement Australia, about their pathways towards emissions reduction and the great work that they're doing in general. We were really pleased to have this conversation in Brisbane, which is on the lands of the Turrbal and Yuggera people. Very proud to pay our respects to elders past and present. Let's go over to Olivia and Bruce now.
So Cement Australia is one of Australia's major producers of cement, and you produce all sorts of different products for the built environment. So, your products are going into concrete producers, into engineers, into a whole range of different supply chains. Can you tell me a little bit more about the structure of the business and what it is that you do?
Okay, so many years ago, there was Queensland Cement Limited and Australia Cement Holdings. And I'm not sure when, but probably about 20 years ago, the two companies merged and created Cement Australia. And since then, we have become the biggest supplier of cement in Australia, in all states, as well as supplying fly ash and ground slag as well. So we have two cement kilns, one located in Gladstone and the other in Tasmania. There are two other kilns in Australia, one in Berrima and the other in Adelaide. So we have the ability to have a completely integrated business from sourcing the raw material.
So can you tell me a little bit about where we sit in the concrete sector right now in terms of some of the major challenges and barriers that are facing the sector?
In this world that we now live in, the public is very aware of sustainability, and this is driving a lot of innovation within the cement and concrete industry. In fact, we are committed to delivering net zero by 2050, which, bearing in mind that cement is one of the big, or the manufacture of cement is one of the big global emitters of greenhouse gases. The numbers vary between 5 and 7%, depending on who you speak to. But that's really the big challenge that's facing our industry. But we are rising to the challenge. There's a lot of innovation that's going on both in the cement manufacturing space as well as the concrete producer area too. And we feel very confident that we can achieve those ambitious targets by 2050.
Fantastic. And just to dive into that a little bit more, we're often hearing that cement is a hard to abate sector. And that's really fundamentally because it's a high temperature sector, right?
It is, but it's not just temperature, Claire. When you turn limestone into cement, you actually emit molecules of carbon dioxide. It's called the calcination reaction. And so it's not just about burning fossil fuels to generate heat inside the kiln. It's actually a fundamental process of the conversion of limestone into clinker, into cement powder. So you can't get away from emitting carbon dioxide. The challenge is what we do when we emit carbon dioxide. What do we do with it? And how can we capture it and reuse it? And that's something that we're really quite advanced in addressing.
And so I'd love to hear a little bit more about how you're tracking down that pathway. So I understand that you're working with some major partnerships at the moment to look at a different pathway to capture that carbon.
That's absolutely right.
With a byproduct being methanol.
That's correct.
As a green fuel.
That's correct. Cement Australia is working closely with the Queensland Government and also the Mitsubishi Gas Corporation. And essentially at our Queensland facility, we are going to work with renewable energy sources to effectively split water into hydrogen and oxygen. We take the oxygen and we use that to enrich the burning environment within our kiln. And what that will do is create a pure stream of carbon dioxide leaving the kiln. We can take it in the gaseous form, and what Mitsubishi will then do is combine it with the hydrogen from electrolysis of water to create a unique building block chemical called methanol. And methanol is used in a wide variety of different chemical products, from laminates to rubber to even fuel. It can be burned as a fuel. Not that we advocate that. We want to use it for getting away from electrochemical sourcing of methanol. In so doing, you effectively minimise the carbon emissions, not eliminate, but minimise the carbon emissions associated with cement manufacturing.
That is incredible. Really exciting space to watch, and thank you for breaking it down to my first year chemistry level. I feel like I've followed you all the way through there.
No problem.
So I guess the other conversation to be had in the sustainability space is this question of cement replacement. And you're obviously working in fly ash and slag as supplementary cementitious materials. Olivia, I know that you've spoken before about the pathway for supplementary cementitious materials, and I guess where there is some focus at the moment is on limestone calcined clay being a replacement, but you don't necessarily see that as a pathway in Cement Australia. Would you be comfortable to tell us a bit about how you see that journey or roadmap for supplementary cementitious materials helping with this emission reduction plan?
Yeah, I think there are a number of materials that people are talking about. One in particular, LC3, like you said, which is the limestone calcined clay, but in gypsum and clinker cement used to replace, I guess, what we call just general purpose cement. But the issue there is that it still needs a process, and with processing there's carbon, there's cost. And there are a number of estimates that we find more efficient. The savings of carbon would be much better than looking at something like calcined clay. And there are other materials that we've been looking at. So I think it's important not just to look at, in theory, what could lower, I guess, the amount of embodied carbon in cement, but look at, is it available? Is there volume? How much does it cost when it comes to processing? Like, for instance, calcined clay, you need either a flash calciner or rotary kiln. And as Bruce already said, how many kilns that we have, the likelihood of us implementing or I guess putting money towards a new kiln is very low. So we have to look at other options that require less processing, whether that's heat, whether that's chemicals, just other factors that we need to consider in order to, I guess, use a material that we would consider as more sustainable. There's a lot of work that we're doing around the space, but those are just some factors that we consider.
Yeah, it's fascinating. And I think it really talks to the fact that these are highly complex issues. And we can't just talk to the technical performance of a particular material in that cement replacement conversation. We do need to be really holistically about the circular impact, the life cycle assessment of the carbon. So yeah, that's really interesting. The way that I envision it is you're actually quite able to do a lot of this research in-house. Can you tell us a little bit about those facilities and the types of research that you're doing at the moment?
Yeah, certainly. We have a very competently manned laboratory in the western suburb of Brisbane. We think we are capable of carrying out a lot of quite groundbreaking research, particularly in the areas, as Olivia has highlighted, alternative and supplementary cementitious materials. That is what we believe to be the future of low carbon concrete mixes. But to be able to demonstrate their suitability, both in terms of cost effectiveness, embodied carbon, and of course durability, we need to really push the boundaries as to how concrete can be tested for long-term performance. For example, at the moment we're focused a lot on carbonation of concrete, and when you drive cement out of concrete mixes, it could be at the expense of long-term durability with respect to its resistance to carbonation. That's something that we're testing right now.
Which is a really, really topical conversation when we think about the broader context of how we're tracking life cycle carbon
Yes.
and there's still reinforcement as well. SmartCrete is really here to try to enhance the industry research collaborative capacity in Australia. Are you doing research with universities at the moment? And if so, what would you say works really well, and what would you say doesn't work quite so well in those collaborative relationships?
Okay. We have worked closely with some academic institutions in the past, and we have generated some useful data. That said, in modern day now, we're not working with too many. And there's a number of reasons behind that, but we think we can do research pretty well ourselves, and so we don't necessarily need to rely on the academic institutions to help us with that research. That's probably one of the biggest reasons why our engagement with universities has, to some extent, tailed off. And another reason is we find that universities generally have their own, they want to paddle their own canoe, for want of a better word. We know what we need from research, and that doesn't necessarily tally with what academic research wants to do. I'll give you a good example now. Example, geopolymer concrete has for many years been a real focus for university research. We at Cement Australia, we believe there's an easier way of achieving the same goals without the need for geopolymer concrete mixers. That's not to say that they have an application, a niche application, they do. But a lot of universities still want to research geopolymer mixes, and for us, that has no commercial relevance.
So what would your advice be if you were talking to a group of academics who are really keen to do very applied research towards industry objectives? What would your advice be to them in terms of speaking to and understanding what your challenges are? How can they understand? Come and talk.
Come and talk. That's all we ask.
Yeah.
Rather than
So your doors are open.
absolutely,
Yeah.
always. But please don't come and tell us what we should and shouldn't be doing.
Yes.
With all due respect.
Yeah.
Please come and listen to what the challenges that we are facing. It's, I've already mentioned it, the biggest challenge to our industry is sustainable concrete production in the future.
Yeah, absolutely. But it sounds like you have many incredible irons in the fire in terms of that transition pathway. So can I ask you both then, thinking about maybe the next 10 years or even our pathway to 2050 with the net zero targets that you have, what are the things that you're really excited about seeing on the horizon?
I think for me, just going on what you both were talking about regarding academics, I like the gaps to close. And I think there's nothing wrong with having industry and academic collaboration, but I think it's really important that academics understand the constraints and the limitations of issues that industry are having and work hand in hand. I think one thing that's really important to me is working together, because in order for us to achieve, our carbon emissions, and it's just not us as an industry, it's us globally, everyone, we have to work together. But I think I'm really excited to see what the future holds for cement, for concrete as a whole, what type of materials we'll be putting in cement. I would like to understand. We talked about some of these alternative SCMs, and I guess a lot of people being hesitant to use them because of the lack of data. I think maybe in 10 years we should have more data. We'll have some answers to these questions that we have. So I'm really keen to see that.
I agree. I mean, there's a world of opportunity out there, particularly in the area of recycling some of the waste materials that have been dumped over the years from the power stations. That's a really key focus for us, and we think there's some low-hanging fruit out there, and that's where we're focusing our research.
Fantastic. Well, Bruce and Olivia, absolutely fantastic talking to you today. Thanks so much for joining me on Clinker Chat.
No problem.
Thank you.
Thank you, Clare.